Hi guys, so today our topic is systems of simultaneous linear equations. Now in your lower classes you have done simultaneous linear equations, but in this higher class you will be doing lot more. Okay, you will be taking simultaneous linear equations, okay, as a group and try and anticipate or tell what they will give us. For example, which of them is supposed to be consistent and which inconsistent, and why consistent. You have to unfold the truth behind consistency of simultaneous linear equations, both algebraically as well as graphically. Now, consistent, okay, system of simultaneous linear equation also can be divided into two parts. While one is independent, the other one is dependent. While one gives one unique solution, the other one gives infinitely many solutions. While one is intersecting lines, okay, the other one is coincident lines. In this case, the scenario is totally different. It does not produce any solutions and they are parallel lines. Now this may be seeming a little ambiguous, little confusing, little baffling because there is lack of clarity. All right, now I'll take you through another slide to make you understand better. All right guys, so here we are. Now this is going to make sense to you because I have given a graphical representation of the three kinds that we have discussed earlier. What were the three kinds? Consistent, okay, inconsistent, independent, and dependent. And the third one was inconsistent. Now this is supposed to be consistent. These two are consistent. And how do we separate consistent from inconsistent? One line answer is that these two are consistent because they give us at least one solution. Alright, they give us one solution and this does not give at all any solution. Alright, so these are intersecting lines, this is overlapping lines, and this is parallel lines. So this is consistent, at least one solution we get from them. There is an entire different story about this. So this has got infinitely many solutions shared by them, which is why they are called dependent consistent. Okay, you would not say this line M or L independently having, okay, any point like this one. If I consider this as line M and this as L, I would say that there are so many points in line L and M that is independent of each other. This one, as they are lying, okay, overlapping, all the points are shared by them, which is why this is called as dependent consistent. And this one is, okay, not having any common point common to both the lines, which is why this does not produce any solution. All right, now coming to the ratio comparison. Okay, usually students find this a little tricky or little confusing, because when we talk about a1 upon a2 not equal to b1 upon b2, what does it mean? Or a1 upon a2 equals to b1 upon b2 equals to c1 upon c2, what do they indicate? They indicate so many things, okay, which is the finding of this, okay, system of simultaneous linear equation. When you are able to unfold this, see, 2x plus 3y equals to 16 and x minus 2y equals to 1. This is one system of simultaneous equation which says that this is 2 and this is 1 as coefficient. So a1 is 2 and a2 is 1. b1 is 3 and b2 is minus 2, which means what? 2 upon 1 is not equal to 3 upon minus 2. As soon as you get this, you would know instantly that graphically they are intersecting lines. All right. Now, once you find out, okay, they all producing equivalent fractions, okay, equivalent ratios, like for example 4 upon 12 here, or 5 upon 15 here, or 7 upon 21 here, they all are equal to 1 upon 3, 1 upon 3 and 1 upon 3. As soon as you get something like this, you would know that the lines have to be coincident. So the moment they give you questions, okay, to find out, okay, whether this is coincident or not, so immediately you have to plug in to finding out whether they all are lying, okay, equal to each other or not. And your answer will be yes for this. And if you get something like this, you would say no. And if you were to find out, okay, graphically the solutions, you would then have to find out, okay, this portion as x and this portion as y from here, from the graph, and tell the unique solution. Okay, but you have to see that which door is open for you to come to the question that they ask you. Okay, now here you have a1 upon a2 equals to b1 upon b2 not equal to c1 upon c2. As a result, we find that 3 upon 6 and 5 upon 10 can be 1 upon 2 and 1 upon 2, but this is 1 upon 3, which means C1 upon C2, okay, is not equal to the rest two pairs, right? So you know immediately that this is going to have parallel lines. Am I right? So do you get it? It will be like that. So to sum it all, by seeing the ratio comparison, okay, we can say that this particular thing will produce intersecting lines, will also produce one unique solution, will also be consistent, whereas for this we know that they will be coincident lines, okay, coincident lines having infinitely many solutions, so many solutions, right? And we also call this as consistent as well as dependent. And for the third kind, where b1 upon b2 or a1 upon a2 are not equal to c1 upon c2, for example, this one will be considered inconsistent, okay, inconsistent, and the graph of it will be parallel lines and it will produce no solution. Okay, so based on this entire thing, you will be asked so many questions. Like supposing they give you, okay, the pair of, say they give you pair of linear equations, whatever they may be, and they'll ask you, what do they represent? Do they represent coincident lines? Do they represent parallel lines? Do they represent intersecting, or none of them? They can also ask you questions, okay, such as draw, okay, on a graph sheet, okay, two system of simultaneous linear equation. They may also ask you to find the area that has been enclosed by, say, x-axis or y-axis. Am I right? So there will be a lot of things that you will be asked. Sometimes they ask you, there will be k over here. Supposing k is here, kx minus 2y, they might ask you, well, this system of linear simultaneous equation, okay, is, okay, in intersecting line, or it has one unique solution. So in that context, try and find out the value of k. They can give you to find out the value of k in general for consistent. So you have to find out, okay, the value of k putting, okay, these ratio comparisons. All right, so there will be a lot more from this chapter, but these are the basics. If you have these completely known to you, there will be no difficulty at all. Okay guys, so I hope this is very clear to you. In case there is still any query, do ask me in the comment box. Okay, I shall again take over this. Okay, so they are far more complicated. Okay, so I'm going to bring in another video regarding all the kind of questions that they give, and I am also posting a lot of them in my shorts. If you haven't gone through them, you will find that I have already given how to find out the k value under the conditions given over here. All right, so once again I'll take you through what I have just now explained you as a summary. So now it makes sense now better, because what is consistency or inconsistency, okay, regarding in terms of simultaneous linear equation. Consistent, okay, can be independent as well as dependent. This will have unique solution, and this will be intersecting line system, right? Infinitely many solution for dependent, and why it is called dependent, and the lines will be coincident. Here inconsistent system of simultaneous equation will produce no result, no solution, no x and y so far, and then it will have graphically parallel lines. Okay guys, so I hope it is clear now. In case you need any further video on any other topic, do write to me in the comment box, will be appreciated. Thank you so much for giving me your valuable time. If you subscribe my channel, I'll keep going. That's what I can say. So I need your support. I hope you realize that. Thank you so much guys. Have a great day. Bye bye.